Hello students, welcome to Organic Embers YouTube channel. In this video, I am going to compare the rate of electrophilic aromatic substitution for given molecules. Many students have this confusion how to write the given aromatic molecules with respect to their rate of electrophilic aromatic substitution. For this, first you should know what is electrophilic substitution reaction, that is, it's very common for aromatic molecules where the hydrogen on the benzene ring is substituted by groups like chlorine, methyl, nitro, right? So these are some of the examples for electrophilic substitution reaction. Since it is very common for aromatic molecules because they want to retain their aromaticity, right? So you should also know what is the rate of reaction. That means the moment there is a group on the benzene ring, what happens to the rate? It depends on the group present on the benzene ring. If it is electron donating through resonance or inductive effect or hyperconjugation, it usually activates the benzene ring towards electrophilic substitution reaction. If there is a electron withdrawing group through inductive effect -I or -R, then it deactivates benzene ring and its rate would be usually less. That means what? If there are multiple groups, right, like chlorine, CH3, NH2 like this, if you have to compare them, you should know whether it's electron donating or electron withdrawing. If it is donating, whether it is through resonance or hyperconjugation or inductive effect, because students remember that resonance predominates over hyperconjugation over inductive effect, right? So these are some of the basic concepts. As we go on, I'll be explaining you what concept I am considering. Alright, so let's take these molecules 1, 2, 3, 4. I'm going to number them as 1, 2, 3, 4. Let's compare these. What is the rate of electrophilic aromatic substitution for the given molecules? We have hydrogen, chlorine, methyl and NH2. NH2 donates electron through resonance +R. Methyl donates electrons through +I. Remember, chlorine, although it donates electron through resonance, it can also withdraw electron from the benzene ring because of its -I effect, that is negative inductive effect. So here chlorine is the only group which is withdrawing electron, right? So 2 should be at the end. And you see here hydrogen neither gives nor takes, right? So that should come next because these two are donating. Now we have inductive effect for methyl and resonance for NH2. And remember, always resonance predominates over inductive effect. So this is the right order. So whatever you know, extreme ends especially, you can write them first. If it is a multiple choice question, then it would be easier for you to identify the right option. Alright. Now, on benzene ring, we have nitro groups. Students, remember, nitro is an electron withdrawing group. If there are electron withdrawing group, they deactivate benzene ring by withdrawing electrons. More the number of electron withdrawing group, the benzene ring will be more and more deficit. So further undergoing reaction would be less, because if it is already electron deficient, why an electrophile which is again electron deficient will attack the benzene ring, isn't it? So if there are electron withdrawing group like nitro, it should go in the end. More the group, more deficit will be the benzene. So this benzene doesn't have any electron withdrawing group. That means it is more electron rich. This is least, right? So that's why the order is this. Now, whose rate is greater? Whichever donates electron to benzene ring easily. So oxygen is negative charge. That means it donates more electron quickly, much quickly, because it's already ionized. So I would prefer to write it in the beginning, right? So that is the highest. And do we have any electron withdrawing? Check here. Yeah, this molecule is electron withdrawing, so I will keep it in the end. Now I have aniline and benzene. You already know that because just now I explained, right? Aniline would be greater, so it will be 2 and then comes the benzene. Right? Much simpler. Now, this is very interesting and confusing for many students also. Okay, we have a isopropyl and tertiary butyl and methyl group on the benzene ring. While explaining inductive effect, we say tertiary butyl carbon donates more electron than isopropyl than methyl. But remember, here we have to take hyperconjugation also into consideration. So what is hyperconjugation? It is a no bond resonance structure from the alpha hydrogens. So we have a benzene, there is a alpha carbon, we have 3 alpha hydrogen. So that means methyl donates electron to the benzene ring through hyperconjugation, and more the number of alpha hydrogen, more will be the no bond resonance structure, more will be the electron donating. If the more electrons are donated, its rate of reaction would be higher. So 3 is greater. Then what about here? We have at least 1 hydrogen. That's why 1. And here we don't have any alpha hydrogen, right? So 2 will go in the end. So this is the correct order. So remember, here hyperconjugation predominates over inductive effect. That's why we have to count the number of alpha hydrogen. Based on that you can arrange it. Now let's move on to the last molecule. Remember, whenever we have a functional group like with the heteroatom like oxygen, nitrogen, it donates electron through resonance, right? But here we have hyperconjugation. So hyperconjugation is less priority as compared to resonance. So that's why 1 I will keep it in the end. 1 we will keep it in the end, the least. Right? Now between 2 and 3, how do you choose? See, 2 will be highest as compared to 3. Why? The lone pair, solely it is given to the benzene ring through resonance. But here the lone pair sometimes might undergo resonance with this ester CO group. So that means it is not as electron donating as compared to this one. Therefore, this will have more rate than this because at least it is giving as compared to the hyperconjugation. That's why the correct order here is 2, 3 and 1. This is the right order of electrophilic aromatic substitution. So how do you arrange electrophilic aromatic substitution? Based on the group present on the benzene ring. More the electron density it is giving to the benzene, more easily it will undergo electrophilic substitution reaction. Thank you for watching this video, and if you have any doubts on this topic or any other topic, you can always write to me to my email ID, or you can drop them in the comment section. I'm going to help you with those questions by posting a video on it. Thank you.